Hello everyone. You're on the SuperKit channel. I have a power station with a battery capacity of 2 kWh, and in principle my computer already runs for about 20 hours on a single charge, but how can the runtime be increased even more? This especially concerns stations that are not that large in capacity. For example, the Ugreen station with a battery capacity of 680 Wh, from which the computer runs only about 5.5 hours. In both cases, during long computer operation, half of the capacity is eaten up by the power station's inverter. That means the inverter needs to be eliminated from the equation. With laptops everything is clear, you can simply use 12 volts, just buy a converter to the required voltage for the laptop and not turn on the inverter at all. With desktop computers things are more complicated. At some point I had a mini monitor on test that could even be powered from a power bank. And my previous 27-inch monitor actually ran on 19 volts, having an external power supply that could be replaced with a DC converter from 12 volts to 19 volts. This also causes losses because of such conversions, but they are definitely noticeably smaller than when increasing the voltage to 230 volts with an inverter, which will then still be lowered by the computer's power supply to different voltages, while the highest voltage even in a desktop computer is still only 12 volts. That's why it makes sense to connect to low voltage in order to save electricity. In the previous video there was a test of my new 27-inch monitor, which works from an external 12-volt power supply. I bought this monitor specifically for connection versatility. Unlike various other monitor models I've seen, the connector plug in the electronic manual, the only place where the plug format is even mentioned, is specified as 5525, which definitely makes both cable and plug searching easier. However, if you take a closer look and compare it with another cable with a 5521 plug, you can see that they are completely identical and fit into the socket with the same effort, while a 5525 plug inserts into a 5521 socket with almost no resistance. It's hard to imagine anything more standard than a 5521 plug. Extra thanks to MSI for using such a plug on the monitor. For connecting routers there are cables with triggers that pull the required 12 volts directly from USB, which makes everything much easier. Especially when those cables have already been purchased. But what to do with the computer? At one point I even wanted to switch to a mini computer that is also powered via USB, requiring 20 volts, however I hesitated for a long time because a desktop computer, at least the one I already have, is simply more powerful. And the price of mini PCs, and now also laptop-type RAM sticks and SSDs, is such that those who bought them earlier got richer today than Bitcoin owners. I knew there were adapters that allow a motherboard to be powered from an external 12-volt power supply, because I had seen such cases for sale, but I hadn't seen such adapters sold separately without cases for a system unit in regular stores, completely forgetting about the existence of AliExpress. And when I decided to search there, I was basically stunned by how many different ones there are. Computers are different, so it's worth noting that in my case I will be using a computer with an ASRock motherboard, an Intel 11th generation processor, 2 RAM sticks of 16 GB each, a 2 TB hard drive, as well as an SSD M.2 NVMe 256 GB. The processor's turbo boost is disabled. After receiving the board for powering the computer, I decided to test it first without the computer, simply with a tester, and noticed some strange behavior. After switching on, the voltage first reached the required value and then kept dropping to very low values for a computer. Nevertheless, I connected it to the motherboard and it seemed to work as it should. Almost as it should. As it seemed to me, the best option for connecting the computer was the cigarette lighter socket on the power station, but once again I became convinced that this is an unreliable connector. Over the years I have connected different devices there, but every time, despite the declared parameters of such connectors and support for up to 10 amps of current, I observed heating of the connector, which indicates poor contact. And this time, while performing test connections, I noticed inadequate heating of the connector. The metal contacts heated up so much that it was impossible to touch them. And this was literally after 10 minutes of test connections under not even that high loads. Today an ordinary USB cable can carry much higher power. Problems with contact quality are also indicated by the not entirely adequate behavior of the voltage. It constantly changes. One could again say that a specific cable or connector in the power station is to blame, but I connected various devices with cigarette lighter connectors to different stations and it was always like this, which is why this time I decided to check how hot the cigarette lighter plug had become. I came to the conclusion that despite the fact that the barrel connector is rated by the power station manufacturer for only 3 amps instead of the cigarette lighter's 10 amps, I would continue working with the 5521 connector. This removed the heating and the voltage became stable. My U-green station came with a cable that has a 5521 plug on one side and 5525 on the other. In this case that turned out to be a plus, because the power connector on the board that connects to the motherboard instead of the power supply is exactly 5525, while the 5521 plug does not fit into a 5525 socket. It is also impossible to ignore the fact that power stations may output anything but exactly 12 volts from the 12-volt port, so I will use a recently purchased voltage stabilizer that outputs 12 volts from an input range of 9 to 35 volts. I don't think anyone wants their computer components receiving 14 volts instead of 12 volts. The initial familiarization with how this setup works is complete, so it's time to fully power the computer from 12 volts. And so the setup is assembled. I'm ready to turn it on, but another nuance appears: the monitor doesn't work. I couldn't understand what was wrong. I replaced the cable, including a shorter one, removed the 5521 splitter from the chain, but the monitor still wouldn't turn on and didn't show any signs of life. Then I decided to connect it through a cable with a built-in trigger, and voila, the monitor worked. So what do we get? The monitor's power supply outputs 12.2 volts, the voltage after my stabilizer is 12.4 volts, and the monitor's protection wouldn't allow it to start. The voltage through USB via the trigger cable is 12.1 volts, everything works without problems. Therefore the scheme was changed and the monitor will be powered via a separate line from USB. In some way this is even better, because I was worried that together with the computer the load on the 5521 connector of the power station would be too high. Now the load is divided not only across different connectors but even across different voltage groups on the power station. After long operation and various tests, during which the processor was loaded in i5-11500+, I did not notice heating in any node, neither at the plug connections, nor at the ports on the power station, and even the stabilizer showed no signs of heating. So I consider the system stable and ready for permanent use. At the same time the total consumption of the system unit at idle plus the monitor when powered from 12 volts was about 38 watts, and under load with the i5-11500 stability test and the CPU at 100% it was about 57 watts. Connecting the computer and monitor to 230 volts from the power station causes consumption of 33 watts without CPU load, and with the same i5-11500 test, 51 watts. The numbers look smaller, but I don't believe them. The power meter through the inverter has long been noticed to be inaccurate. Perhaps it is difficult for the power station to calculate how much the inverter itself consumes and how much the connected devices consume, because the inverter's consumption is not indicated on the meter. Apparently it's all calibrated somehow there, but it's obvious that this consumption not only exists, it's huge. When the inverter is simply turned on and running idle, the remaining estimated runtime of the power station is almost the same as when the computer with monitor was running from 12 volts without using the inverter. I trust my wattmeter much more. It shows that when only the computer is connected to the mains without the monitor it consumes 33 watts at idle and about 54 watts with the i5-11500 test. As could be seen in the monitor review, it consumes another 16 watts. That means the computer and monitor together consume about 50 watts at idle and about 70 watts under full CPU load. Seeing these numbers, which may not be absolutely precise, everything makes sense to me personally, because I trust the readings without using the inverter on the power station more than with it. The inverter can distort the understanding of real power consumption since its own consumption is not constant and depends on the load, and the station may assume that the inverter itself consumes that power rather than the connected devices. As a result, from a fully charged power station with a battery capacity of 2 kWh, when using the 230-volt inverter, my computer with monitor can run about 20 hours, and from 12 volts, about 40 hours. What if you have a discrete graphics card? First, you should evaluate whether you really need it and perhaps switch to using integrated graphics. Second, understand the real power consumption of the graphics card. There are 12-volt computer power boards that claim loads up to 300 watts. I personally don't believe that, but as an option you could buy 2 such boards, connect everything except the graphics card to one, and the graphics card to the other. There are boards with separate power for the GPU and 6-pin connectors. The adapter I bought powers only the motherboard, the CPU 8-pin, as well as SATA and Molex connectors for hard drives or SSDs. With the help of a PSU synchronization adapter you can make both power sources start simultaneously when pressing the computer power button. This allows increasing the maximum power of a computer that you want to convert to 12-volt operation. It also allows the load to be split between the power station's connectors. When trying to power the computer from 12 volts I encountered various difficulties. Sometimes the cigarette lighter connector overheated due to poor contact. Sometimes 12 volts were not really 12 volts and equipment could be damaged, which is why a stabilizer is definitely necessary. Even a difference of 0.2 volts compared with the monitor's power supply prevented the monitor from starting and the wiring scheme had to be changed. I'll also add a story from my personal experience. I once bought a USB plug with a 12-volt trigger and connected it to a power bank with a maximum output of 12 volts, everything was perfect, 12 volts on the output. But I have a habit of checking what happens in other situations. So I connected this trigger to a charger that can output not only 12 volts but also 20 volts, and 20 volts appeared at the output. If I had connected a 12-volt device and plugged it into that charger, the device probably wouldn't exist anymore. That's why I always check such trigger cables to see what voltage they actually output from a specific USB port. In this build, as you could see, besides checking I specifically connected such a cable to a port that cannot output more than 12 volts. But I still checked. This way of using a power station allows you to save a lot both on the station itself and on buying a larger capacity model that would otherwise be needed not only for charging a tablet but also for running a router and a desk lamp. The simplicity of the design and the universality of the connectors in my case make it easy to return everything back to normal. Nothing needs to be soldered here, and the most complicated connector to reconnect is the power connector on the motherboard. If your computer consumes little power, you could avoid reconnecting anything at all by buying an external 12-volt 10-amp power supply and using the computer like that all the time. There is also a benefit. Power consumption will be lower, the external power supply has no fan which means less noise, and there will be less need to clean dust from the system unit since the internal PSU fan will no longer suck dust inside through every gap in the case. These are exactly the kinds of actions I had in mind when in one of my videos I suggested thinking about converting your equipment to low voltage power. As you could see, my computer which usually consumes about 33 watts after the operating system loads consumes only about 20 watts when running from 12 volts. So not only did the overall power consumption become lower, but the fact that the inverter is turned off also saves battery charge. All this results in at least a 2-fold increase in the autonomy of this setup. Even a power station with only 680 Wh capacity predicts more than 10 hours of computer runtime instead of 5.5 hours when working through the inverter. Of course, if you have the financial ability to cover the inverter's losses, which will eat up half of the power station's capacity, then maybe it's not worth bothering with all this. Links to useful stuff are in the description. Rate the video. Subscribe to the channel, there will definitely be more videos about different devices. If you have questions, you can ask them in the comments. I'll try to answer them. Thanks everyone and see you next time.